Hello everyone, welcome to Big Data Thoughts. Today we are going to talk about data lakes. We'll talk about what is a data lake, the entire evolution of data lakes in the last couple of years, and we will focus on what are the 10 best practices when we want to build data lakes. So let's get started. So what is a data lake? First of all, let's look at what does a data lake mean. Data lake is nothing but a centralized repository that will allow you to store any kind of data, whether it is structured, unstructured, or semi-structured, any kind of data. And ideally, a data lake is meant to scale, which means that whatever is the volume of data, whatever is the type of data, the data lake will act as a single centralized storage, and there is no need or enforcement to have a particular structure of the data. So any kind of data can be stored into a data lake. And one thing to keep in mind is this is where, so I've spoken previously also about distributed systems and the way the data is stored and retrieved. So in a data lake, any kind of data can be stored because there is no schema enforcement when the data is put into a data lake. Only when we try to read the data, that is when we try to enforce or put some schema over it. So all in all, in a data lake, it is always a schema on read and not a schema on write, which means you enforce schema only when you are reading the data. Based on your consumption pattern, based on your usage, would you enforce some schema. So data lake is nothing but a centralized repository. Now let us also talk about the evolution of data lakes, because data lakes, this concept of data lake has been there for a number of years. But the way the data lakes are structured, the way the data lakes are created, and the way we access it has changed over time based on the need and based on technology advancement. So if we look at the data lakes, how they were previously, so they were mostly batch oriented. The way data lakes were getting used a number of years back or a couple of years back was primarily to run a batch of ELT. ELT is extract, load, and then transform. Because in a distributed system, in a big data system, we first load the data without enforcing schema and then we do the transformation. So ELT was done at a specified time. Once a day, twice a day, weekly, monthly, whatever it was more batch oriented. It was primarily on-prem to begin with because people were not that open to adopt cloud like they are today. So it was mostly on-premise that data lakes were built. It was a pure play. When I say ETL, in a big data setup, it will be ELT. But just for understanding's sake, the whole use of a data lake was more from the standpoint of running a ELT job once a day or twice a day and then bring in the data and put it in the data lake. It was very heavy on the ingress part, meaning there was a lot of focus on bringing data because people thought that a data lake is something where all data can be just brought in and kept, kind of going towards creating a data swamp, which is one of the biggest problems of a data lake. So it was mostly initially very heavy on the ingress. There were multiple sources from which data was brought in and put into a data lake. It had very stringent rules. It was very rigid in the sense of how the data was stored, how the data was used. There were only specific use cases that were looked at. It was less user friendly. Of course, some limitations were the technologies that we had at that point of time when data lakes started. So they were not very user friendly as compared to today. Primary usage was as a decision support system. That was the primary use case of a data lake. And there were very low integration touch points. Ideally, a good data lake would be some data lake where you have very good, well-established integration points so that you can actually have a lot of flexibility while building and using the data lake. So this was all about how data lakes started. But if we move forward and we see today where we are, how the data lakes are built and consumed, is they have higher velocity because the amount of data, the velocity at which we are receiving data has increased multifolds. It is on cloud. Mostly the use cases that we see today or the data analytics platform, the data lakes that we see in different organizations is on cloud because there is a huge adoption of cloud and multi-cloud as well. Another thing that has happened today is that it is no longer an ingress or an ingestion heavy data lake. So both of ingestion as well as consumption are have become heavy, which means that there are multiple sources from where the data lake is getting the data, and there are different kinds of consumption patterns that are there or are frequently used. It's a multiple workload kind of a data lake, not just restricted to having a ETL or a ELT, so to say. It's not about just setting up a ELT to occur at a in a batch oriented fashion at a stipulated time, but it is much more than that. The kind of workloads, the kind of use cases have actually picked up, and there are a lot of different scenarios that are there. The data lakes are more flexible and agile because of the advancement of technology, with the advancement and maturity of the data lakes, they have become very, very flexible and agile to accommodate new ingestion patterns, to accommodate new consumption patterns. They are very, very end user friendly. So users do not have to deal always by writing SQLs or by writing programs. It's much more friendlier with different kinds of outcomes in terms of reports, dashboards, ad hoc analysis, doing the exploratory analysis of data. So there are multiple ways in which the data lake can be consumed. It has, like I said, varied use cases. It has much higher integration points. So this was all about what is a data lake, how did it evolve. But now we would look at 10 best practices that should be followed when we are designing data lakes. So first of all, the most important thing to remember is that a data lake should not become a data swamp, which means it should not happen that because a data lake can store any kind of data and at any volume, we just start ingesting data from all the systems that we have today and try to create a central repository. That is not a right way to do it, because that will make the data lake a data swamp. It will be very difficult to govern that data lake, to clean the data, and also to even maintain that data lake. So it should always and always be built incrementally. It should always gradually evolve, which means even though the data lake has the capability to store all of the data that is there in any format, but as a user or as a creator of the data lake, it has to be a conscious decision as to what data we want to bring into the data lake, what really makes sense. And it can be a phased approach where we decide about top use cases and bring them in, and gradually we build the data lake. So it's a evolving process, and it is not something which should become a data swamp. That's the first thing to remember. Then comes the onboarding process. What do we mean by onboarding process? Onboarding means, since we don't want to put everything together and we don't want to build a data swamp, we want to build it incrementally, we definitely have to have a conscious check on what we are bringing to the data lake, and that can happen only when we have a very well established standardized onboarding process. First thing is to identify use cases, which means in an organization, if the organization takes a decision to build a data lake, they should list out a list of use cases that they really want to achieve from the data lake. Then those use cases should be prioritized, because we don't want to bring everything together, we want to build it incrementally. So the use cases should be identified, prioritized. We should look at what kind of data that use case needs. What is the ingestion frequency, and we will talk about it more when we talk about data consumption, integration and processing, all of that in the subsequent slides. But as an onboarding process, it's very important to identify use case, prioritize, identify who are my consumers, why am I even bringing this data into the data lake, what is the purpose it is solving. That kind of a questioning needs to be there as a part of onboarding process, and there can definitely be a template that is defined to take care of or capture these parameters. So it's critical to do that kind of a profiling of the use cases and then incrementally build over that. The next is the data integration pattern. Now, as an organization, I have decided to go ahead with a data lake. I have identified the use cases, prioritized them, looked at what really is the need and what is the data needed, Now, based on that, I need to check whether that data is coming in real time. Is it batch or is it event driven? Now, what does that mean? If there is certain data coming from one or two sources, whichever I have identified, that data needs to come on a regular basis, maybe daily or multiple times a day. Then that's a best suited candidate for a batch kind of pattern, which means I would identify the set of technologies that are well suited for batch integration and build a pipeline that can bring in data every day and schedule those jobs to run either daily or multiple times a day. If there are a set of is there a set of data which is coming real time, then there would be a different integration pattern established, whether it is coming through Kafka or it is coming through Spark streaming. That really depends on how I am bringing the data. If it is real time, I will choose appropriate technologies and build that kind of integration pattern. When I say integration pattern, it is more about identifying the different types in which I would bring in data to the data lake and then establish those pipelines or mechanisms to pull the data and schedule them if required. For batch, I will schedule them. For real time, it is a continuous influx of data, and there can be cases where it is event driven. So it's based on an event. When something happens, when the data lands into some location or some processing happens, there is a trigger generated and we need to bring the data. So that also has to be identified because these will determine what should be my integration pattern for the data lake. After I have done the integration, the next step now is processing the data. Now, data processing means any kind of cleansing, transformation, aggregation, whatever I am doing on the data. But this data processing can be done in variety of ways. Either if I know that those jobs are long running ones and typically batch kind of scenario where the job is running for a couple of hours. So one way of doing it is we have a dedicated cluster always up and running to run those jobs, because I know most of the day the job data is going on, coming, and the jobs are going to run. Then I can have a dedicated cluster always up and running. Or else I can have a just-in-time enablement, which means as and when the data comes, the cluster comes up and it does the processing, and then the cluster, I can just terminate the cluster. For example, in Amazon, we have the concept of EMR, which means Elastic MapReduce. So the cluster comes up, does the processing, and you can either keep the EMR on always or switch it off, because that will save you cost. So just-in-time enablement. In Azure also similarly, Synapse has pools, like Spark pools are there, serverless pools are there. You can stop that pool or pause it basically. So it will not consume cost. So there are two patterns broadly, which is long running jobs or having a dedicated cluster up and running always. And second is a just-in-time enablement. Both are very widely used based on the use case. And third form is like a serverless. It's not a form, but it is a kind of the way in which we do processing. And most of the time these days we are using serverless because we don't want any headache of actually doing any configuration, bringing up the cluster or anything. It is serverless, which means it is infrastructure as a code, and based on my demand, the cluster will come up, scale, do the job, and go out. So primarily, while deciding on how I want to do data processing, the things to look at are what is the use case. Do I want to have a cluster always running? Do I want to have a cluster just enabled, do the job, and go away? That will depend on my data coming in as well as the use case and requirement. But this is important from the cost standpoint. Then comes data consumption. How do we decide what should be the consumption pattern? So the way we profile the use cases, similar way we should profile our user personas and say that plus the consumption patterns. We should identify whether the requirement for the data is to be available for reporting, whether the requirement is to have ad hoc querying, or the requirement is some data scientist wants a sandbox with a subset of data to do some kind of exploration, build ML models. It's extremely important to understand what we are trying to achieve, the consumption pattern. Just like integration pattern is important to establish those integration patterns and make a robust system which is able to consume different types and forms of data. Similarly, it is very important to understand the consumption pattern because we need to build consumption. It's important to understand the consumption ways, the way we want to consume. That will help in building the consumption patterns. For example, for reporting, we may want to have a data mart build up or a data model built in such a way that it provisions smart data mart tables. For ad hoc querying, we may want to give access to fine-grained data rather than the aggregated one. For sandbox, it's a totally different requirement. You need a different setup. Data needs to go into the sandbox based on the data scientist or anybody's requirement. So identifying these consumptions ways helps in establishing those consumption patterns and automating that. Now, one more important, very important thing is technology choice. Most of the time, people try to fit or use technologies that are in the market and which seem to be very lucrative. But that's not the right way because one is we don't want to over engineer. We do not want to use something which is really not needed. We want to keep our life, developers' life simple, and also the maintenance and ongoing effort to keep the system live, running, and maintain it. We want that also to be simple. So, the technology size, one thing to understand is one technology cannot fit all needs. That is important. There is no over engineering required. It has to be an absolute right fit. That is why when we identify our integration, processing, consumption patterns, appropriate technologies can be selected for each of the use case. So a technology which can serve my batch needs may not serve my real-time needs or event-driven needs. So a profiling of what is needed in terms of getting in the data and getting out the data is important. Then the technology choices will be the right fit. And we should never ever use technologies just because they are good, they are in the market and everybody is using it. It is always based on the need and the use that we have. Then comes another important aspect, data quality. Sometimes when we build systems, we ignore this part and this later causes a lot of issue and the cost increases. If the data issues are found out while consuming the data, it is much more costlier to do the cleanup and re-ingest of data. Rather, it is a best practice to have data quality rules established at the starting when we are bringing the data before even taking it to the finer grain layer or the aggregated layer. We should do a data quality check. That quality check is primarily to ensure the integrity of the data, the completeness of the data. Null checks etc. are very common, deduplication, but overall goal is to see whether the data is complete or not. If the data is missing and finding it out at the later place becomes complicated and cost heavy. So it is better to identify and establish data quality rules, have a configurable data quality rule engine which will have a set of rules which will be applied on every data, and those rules can change over time. So it has to be a configurable data quality rule engine. But this step is a must for any data lake. Then comes data governance. By data governance, what we mean is whatever data is getting collected in the data lake needs to be governed. There has to be a lineage, a audit, a logging of that data to know what came in, from which source, the entire lineage from source till the data lake consumption. If that is available, it is much more easier to debug problems, to onboard new data sources, because the data lineage helps in understanding from where the data is coming, what are the attributes that are getting captured at each layer. So a data governance process needs to be established, and there are many more aspects of data governance, like actually cataloging the data, doing a metadata management. So there are varied aspects, but broadly what the goal is to have a lineage, logging and auditing capabilities so that data can be governed. Now coming to security. Security is also a very important aspect because there are multiple compliances that every a particular industry needs to comply with. One of the basic security thing to keep in mind is authentication. Now, how do you do authentication? Do you want to have a username password based authentication? Does it have to be a AD integration? Typically in organizations, you would have a AD integration and a single sign-on enabled. So it is important to identify what would be our different authentication patterns or how do we want to authenticate. Then authorization. Authorization would be based on user persona. So what kind of, if it is an admin or whether it is a data engineer or who it is, based on that authorization should be provided. It can be a fine-grained authorization where it can be at a row column level as well. Typically on the consumption side, the authorization would be either at row or column basis depending on the person who is accessing that data. The data definitely has to be encrypted. These days, all cloud vendors have provided very easy way of doing all of these security related things. Encryption and all the time, like most of the time built into the cloud service that we are using. So encryption at rest can be done. Encryption in the while the data is in motion can be done. So it's not always that a developer needs to go and code for everything. It's very easily configurable in the services that cloud provides today. But the whole point of having this discussion is that somebody needs to think about all of these things while designing a data lake. And sometimes the decisions that we take in terms of technology choices, in terms of the way our data model looks like, can get influenced by these things where we need to think about how data will be made secure. For example, when I design data model, if I know beforehand that how will the data users will be accessing the data, I want a row level access or a column level access, it will help in even modeling the data. Also, there are requirements of people wanting to have a virtual private network. So most of the clouds, all of the clouds in fact, provide VPN kind of a setup that is possible. So we can select whether we want to have private connections, do we want to have a virtual private network with only some endpoints, not having any internet access, etc. So there are n number of levers available in each of the cloud providers that we can use to enable this. But while designing, we have to think through this beforehand so that it can help us in making our choices. Then telemetry. This is a very important aspect when to think about when we are designing data lakes, and that involves monitoring the whole environment. So we will have multiple environments: development, testing, pre-prod, prod. It's extremely important to have telemetry defined and established in the production to capture what is happening and proactively do fixes. We also spoke about chaos engineering in one of the videos, which is nothing but testing in production so that we can fix things which may break. So telemetry forms an essential part of any data lake or any system that is built, because it will help us to collect the information of what is happening and proactively fix things. So we need to establish, there are multiple tools to do it. But it's just that while designing data lakes, this also has to be kept in mind, and accordingly we decide how do we want to capture the telemetry, which tool do I use. Now last but not the least, cost. Cost is a very important and driving factor when we design any kind of a system. How do we optimize cost? So every cloud service provider provides a kind of a calculator where you can go and have a ballpark of how much cost would you incur if you actually select certain services, certain data volume, input, output, what is the IOPS, right? Based on that, it will give you a fair amount of idea about the cost. But essentially, as an architect or as a designer of a data lake, what we need to keep in mind to have the cost as low as possible or optimized is, first of all, look at what are the technology services that we are using, and then accordingly decide how much cost it will take. For example, if we are using, let's say, Amazon, and we are using EMR, an EMR cluster, if I spin it up and I don't want it for the entire time, I can just kind of have the processing happen and the EMR cluster just goes down. So it's a just-in-time enablement that will save cost versus I take a decision to have a long running cluster because whole day I'm running jobs and I don't want to kind of spin up, spin down all the time. So that's a conscious choice that needs to be made in terms of how I want to process my data, how I want to keep my cluster alive. Or do I want to pause it? So that's a choice that needs to be made. And there is also a need to look at the data storage. So do we need the entire data to be available, whether in a S3 file system or a blob storage, or do I want to archive it? Every cloud provider has data lifecycle policies that you can set in terms of how much active data do you really want always available versus what do you want to keep in archive. So that also plays an important part because we are talking about huge volumes of data. So data processing, both of the things, how we are doing the storage and the processing will determine the cost, the choice of the services that we are making, even certain things like high availability, because in case of critical applications, we may have a copy of our current existing infrastructure just to have an active passive or active kind of a availability setup. Now that will incur cost. If we have a active high availability, that means there are two similar clusters running up and running all the time. So do we really want that, or we want to have an active passive kind of a setup, or we just want to take data snapshots and bring up the cluster. If something goes wrong, we bring up the cluster with the snapshots. So it's a completely a choice that we have to make based on the criticality of the data. And there is one video that I did extensively on high availability. So please have a look at that to understand more what are the different options. But all in all, cost is important. So these aspects, each of the aspects of how we are bringing the data, how we are storing, how we are processing, what kind of a disaster recovery mechanism have I set up, all of this will determine my cost. So this was all about data lakes, how they evolved, what are the 10 best practices. I hope this video helps. Please keep liking, sharing and subscribing to the channel to get more interesting videos. Thank you so much.